All right, 7.3, number 35. Find the volume of the solid generated by revolving the region bounded by y equals square root of x. I'm going to get a big old picture here. So y equals square root of x looks kind of like that. In the lines y equals 2 and x equals 0. Okay, so y equals 2 is eventually going to hit it right there. That's y equals 2. X equals 0 is this, the y-axis. So there's my region. This intersection point would be 4, 2. Because when y is 2, x would have to be 4. Alright, so we've got 4 scenarios. We're revolving around the x-axis, y-axis, y equals 2, and x equals 4. Okay, so first thing, we're going around the x-axis. So if we're revolving around the x-axis, you can see that it's going to be hollow. There's the small circle, and there's my large circle. So this is my washer created when we revolve around the x-axis. Okay, and now washer is always the integral of pi big R squared minus little r squared, and it would be a horizontal, so it's a dx. And since it's dx, we're going from here to here, so from 0 to 4. Okay, so the integral, this is all part A here. Okay, so we need to figure out what r is, big R and little r, and we're basically set up for an integral. So our big R is the distance from our axis of revolution all the way up. And anywhere you put along that interval, it's always going to be the same. What's my big R going to be in this problem? How long is that? It's 2, right? Because anywhere along here, my big R, I mean, I could draw another washer right here, but my big R is always going to be 2. So my R, big R, is 2. And now my little r is this distance right here, and that does change. So it's not going to be a constant, but to represent a distance from the x-axis up is always going to be y. So we could say y here. But the problem with that is we're integrating with respect to x. So what is the y? The y here can also be represented as the square root of x, because this curve is y equals square root of x. So we are not going to use the fact that that's y, we're going to use the fact that it's the square root of x here. So it's the square root of x squared, and that would be our integral. Alright, part A is done. Now we're going around the y-axis. So if we go around the y-axis, it's going to be a solid. So you can see that it's going to be not a washer, it'll be a disk. There's my disk. Okay, it's a vertical axis of revolution, so it's going to be integral of pi r squared. It'll be dy, so we're going from 0 to 2. Okay, so now, just like the distance from the x-axis up is always y, the distance from the y-axis out is always going to be x. Okay, this is x, this is x, those are all x. X doesn't work in this problem. So you'd square both sides, so x is equal to y squared. We solved for x. So another way to write x here is y squared. So it's pi y squared squared, and there's my integral going around the y-axis. Alright, going around y equals 2. So if we go around y equals 2, same area, we're going to you can see that it's going to be, what's our technique? Disc or washer? It's going to be disc. Very good, because it's solid. There's no hollow. There's only one cross section, so I'll make one right there. There's my little disc. Okay, so since it's a horizontal and since it's disc, we're going to integrate pi r squared dx. So dx means we're going from here to here, because on the x-axis we're going from here to here, so 0 to 4. So now we need to represent this radius. There's a radius right there. So that radius, we know that this whole height is always going to be, that's going to be 2, and this height is going to be y, but we want y as the square root of x, so it'll be 2 minus the square root of x. That's my radius. The whole minus the part is this radius right there. And the last scenario, we're going around x equals 4. Alright, so around x equals 4, you can see that here's my axis. It's going to be that kind of shape. Alright, so it's going to be a washer. There's my little r, and there's my big R right here, that whole distance. Okay, so our big R there it is. Okay, so integral, we're going around a vertical, so it's going to be dy, and it's washer, so pi big R squared minus little r squared dy, and since it's dy, we're going from here to here, so from 0 to 2. Now we have to figure out what our big R is and our little r. Our big R is this distance. It's always that distance, so it's going to be 4 no matter what. And our little r is this distance. We know this much of it is x, so it's going to be 4 minus x. 4 minus, this is x, and that's 4, so it'll be this distance right here is 4 minus x. Well, we can't say 4 minus with respect to y, so we'll say 4 minus y squared.